In this video, we will talk about a DC motor, which is the ideal choice for many applications where it's needed. Reliability, low maintenance, less noise, speed control, and low cost. Specifically, we are going to see how a brushless DC motor works. We can assume already by its name that this type of electric motor has no brushes. As we have already seen in our previous video about the working principle of DC motors, the brushes are sliding devices which allow the electricity to flow into the copper coil of the engine. The brushless motors have no sliding elements on the collector, so this completely solves the problem of maintenance and replacement of brushes and other electrical contacts. JAES, in its catalog, offers a wide range of brushless motors of the major manufacturers. Unlike the common DC motors that use brushes for their functioning, brushless motors do not produce sparking or friction noises within them. This is a very interesting feature of brushless motors, because it allows them to be suitable for use in environments where sparks are dangerous. For example, in environments where ignitable gases are present. This type of motor has a rotor with permanent magnets. It could not be otherwise since there are no contacts on the rotor, as we already said. Its stator has electromagnets excited by windings and coils. This is an important difference compared to the traditional brushless DC motor, since the latter can have both stator and rotor composed of electromagnets to increase the magnetic fields and therefore have a higher mechanical power density by unit of weight of the motor. The torque of the brushless motor is due to the magnetic interaction imposed by the electromagnets on the permanent magnets. There is a precise sequence of excitation of the electromagnets which imposes to the permanent magnets an angular movement, which is always in the same direction, and it is as constant as possible under the same excitation. Obviously, the sequence is cyclical and the rotor continues its rotation until it's powered, repeating the sequence from time to time. To be more specific, the sequence of excitation of the electromagnets inside the stator is such that the magnets of the rotor are attracted to the electromagnets without ever reaching them, as the excitation is always and only of those coils, not yet reached. When electricity flows into coil 1, the opposite poles of the rotor and stator are attracted to each other. When the rotor is getting close to the coil 1, the electricity flows in the coil 2. When the rotor is getting close to the coil 2, the electricity flows in the coil 3. Later, in the coil 1, the electricity will flow again, but with opposite polarity. This process is repeated continuously inside the engine, ensuring a constant rotation of the rotor. An example to better understand this principle is represented by the dog race, in which a hare is placed in front of the greyhounds at such a distance to be seen but never reached. In this metaphor, the dogs represent the rotor that follows the magnetic flux generated in exact sequence in the coils of the stator. In the case of more coils, always multiples of 2, it makes sense to use a sequence that uses them all, to increase the magnetic flux to which the permanent magnets are subjected and turning off only the opposite electromagnets. This simple foresight increases the torque, that is the power that the motor can supply, without substantially modifying its design criteria. The greater the number of coils, the smoother is the rotation of the rotor, which will thus have a constant torque. But how does our brushless motor know the precise movement in which to excite the correct sequence of electromagnets, which will allow continuity of the rotary motion? For this purpose, an electronic controller is typically used. This controller has a sensor to detect the exact position of the rotor magnets and thus decide which coil to energize by following the right excitation sequence. The modern brushless motor sensors use the Hall effect. In this animation, we can observe the configuration of a standard sensor. This is a simple 2-pole device that can drive 2 or 4 or 8 or more electromagnets in the just seen sequence. This is instead the representation of a classic circuit layout with protection diodes. The presence of diodes is necessary to protect the sensor from negative self-inductance, in case we need to suddenly block the power supply from one of the coils. There are basically two families of brushless motors, those with an external stator and those with an internal stator. We can summarize the main strength points of the brushless DC motor. Brushless motor is noiseless. It is reliable and has a very low MTBF parameter, which is the predicted elapsed time between its inherent failures. It provides low energy costs, does not require any maintenance. It can also be used in flammable environments. It has more competitive price than traditional brush motors of the same power. However, the brushless motor has also its limitations, like requires an electronic driver in order to control the right excitation sequence, uses permanent magnets. The specific power is generally lower than the conventional motors equipped with stator and rotor. Finally, if you found this video useful, let us know by leaving a comment and subscribing to our YouTube channel to stay tuned on the latest release of new videos. Thanks for watching.